So we will looking at what we call compound interest in this video. Compound interest is just a way of calculating interest over a period of time, and this is actually calculated by what we call a principal. You have the principal, that is, you can actually invest some money in the bank. Say you invest $20,000 and the bank is giving you like a 2% interest rate on that $20,000. So your money will be actually growing over a period of time. And so after calculating how much money you'll be getting for the first year by the investment times the one that you invest times the percentage rate, you'll actually add that interest, because in simple interest we learned that to actually calculate interest in just a simple way would actually multiply the principal times the rate and the time. And so if we should actually look at how simple interest, compound interest is actually calculated. It is calculated by the principal times the rate and the amount of years you'll be actually getting this interest added to the principal. And each time when the interest is added to the principal, it creates or it forms what we call a new principal, and then that new principal will be calculated by the constant percentage rate, and that continues until the amount of year that the investment will last for. And so we'll just be looking at it in two ways. We will be actually solving it by using a pen and a piece of paper, and then we'll actually be introduced to the formula of compound interest appreciation, and then we just look at it two ways, and we actually look if what we do the first time, if there's any correlation with what we will get for the second approach. So let us look at it. Let us use the same example. If I borrow $20,000 at the bank, and the bank is giving me an interest rate on this 2%. Let's say I am actually investing this money for a 3 years period. 3 years period. 3 years period. So the question is, how much money will I have in the bank at the end of 3 years? So that's what I want to find out. So we can actually use a compound interest form, because compound interest is actually interest on top of interest on top of interest. So it's interest adding on top of the original money, and it forms a new money, and it just continues until the time or the duration is finished. So let's look at it. So I could have simply just work this out. Let's say work this out year by year, year after year, year after year. So I could say, let's say, what is 20% of what is 2% of $20,000? So if I should find 2%, we put it. These 2 zeros cancels 2 zeros in that, and so when we times 200 times 2, we get $400. Now this is, let me write this as year 1. So this is actually year 1. Let me change the color. Let me say this is year 1. This is for the first year. Year 1. This is year 1. This is for the first year. So if we look at it, we actually get an interest of $400 on this $20,000. So for the first year, at the end of the first year, we'll actually be having $20,400 in our account or in the bank as an investment. That's why you call it investment. So the thing is that what compound interest does, it increases the investment that you make. So any amount of money that you put in the bank, you're actually making more money on top of the money. And so we will calculate this so for the first year, we'll be seeing this in the account. This we'll be seeing in the account. So if you want to find out what would be the second year, now this is what we call the new principal. Now this was the first principal, the $20,000, and now when we add the interest to the principal, it becomes what we call the new principal. And so we'll be having several new, not several, depending on how long you actually do the investment. So this is what we call a new principal. So what we will have to do is to use the constant percentage rate, because it's going to be a constant percentage rate. So we have to find out 2% of the new principal, and then that will tell us the calculation for the second year, or the increased money as an interest for the second year. And so if you look at, we could say cancel these two, this 0 cancel that 0, this cancel that 0, and if you should multiply this now, we get let's say it's what 408. So this is the second, this is another interest that you get. So this is the second interest for the second year. So that's got it. That's right. So this is the second year. This is the second year. This is year 2. And so what we will do is to add this interest on the new principal, and that will form another new principal. So let's look at it. Plus 408. So we have 20,808. And now, since now we'll be calculating for the last year, that is the third year. And so what we do, actually find 2% of this new principal. And so what we could do, we could actually work this out and just multiply by this. So if it should actually convert this fraction, it will be 0.02. And what we will do is to multiply this by the new principal, which will give us 416.16. Let me check this here. Right, so this will actually be for the third year. This is the third year interest. So this will be your interest for the third year. And so actually we're finished with what we have to do now is to simply add the final interest to the final principal. I will actually get, let's see, this what 21,224.16. And now this will be our this will be the increased, this will be the money, this will be the investment growing after 3 years. And this is what we see in the bank. So the money that we invested would be changed significantly based on the percentage rate over a period of time. But so this is just working it out by just using a pen and a piece of paper. Just look at the concept of interest, just as if you were going to calculate simple interest. But it's not simple interest idea, because interest being multiplied by a new principal, and in simple interest we do not do that. So you just basically calculating it year after year, new principal times percentage rate and so on. So if you look at it, let us look at what we did. So what we did, we find 2% of 20 for the first year, and so we got 400. We add that to the principal, that becomes what we call the new principal, and then we find 2% of the new principal. For the second year we got 408. We add that to the new principal, and we got 20,808. We find 2% of 20,808, and it gives us 460.16. And that's a final calculation for the 3 year. And we'll just add that last interest with the last new principal. So what we're looking at, we will be actually looking at the formula to see if the formula actually gives us the same thing. Plus R over 100. So this is actually the formula to calculate compound interest. And so let us try to understand what are the meaning for these variables. What are these variables? What are they actually representing? What are they saying to us? So let us look at it. So this A represents the final amount of money, or the final amount of money that is calculated over the period of time. So if you should look at this, this is going to be actually, it should be equal to this that we just got over here. Let me see. It would be equal to this that we just got over here. This, it should be equal to this that we got over here. That's the final amount of the investment over a period of time. And so we'll actually be looking at. And so the P is nothing too unfamiliar, I assume, because P normally represents principal. So this P is a principal, which is at $20,000. And this constant is always in this formula. Probably I would actually have to do another video to explain the formula why there's a constant 1. And then we have the rate. There's a rate. The R is the rate, the percent that we actually got from the bank that actually increases the principal, and that gives us the interest. And the N represents how long is this investment is going to last for. All right, so we can just simply substitute the values in these let's say variables and see, and evaluate and see what we will get. And if there's a correlation with what we got first with what we are going to get now. So let's go and substitute. So the principal is 20,000. We have the 1 plus the rate is at 2%. But what we could do, we could actually convert this fraction into decimal. So I should say 0.02 raised to how long? The third power, because we actually calculated for 3 years. And so let's go ahead and work it out. Now, whenever we see brackets or parentheses, the order of operation says that we must work out what is inside of the bracket first. So if we should add 0.2 plus 1, we will get this, and it being raised to 3. So what we could do now is to work out the exponent form, which is 1.02 raised to the third power, and this is actually going to multiply by itself 3 identical times. So let's go ahead and calculate it. All right, so let us go down further and look and see what it looks like. So we have the amount is equal to 20,000, and this is saying 1.02 times 1.02 times 1.02, the exponential form, the exponential in the expansion way. And so this will actually give us, let's use a different color. Let's say use blue. The same color, all right. So 20,000, right? So what is in the bracket? We get 1.061208, and so we actually reached the final step of the calculation. It's just multiply what we got in the bracket now by the 20,000. And so if you should punch this into the calculator, you'll actually get 21,224.16. And so it actually gives us the same answer if we were doing it the other way. So you decide which one of the ways you want to choose, which one of the ways that you want to calculate component interest. But I would work with the formula, because the formula is very, very, very quick, very, very quick, and you never had to do it so detailed like how I did. But I love for you students to see the idea of what it is saying, or the reason of this problem as you go along. So there you go. Compound interest. Simple as that. So if you like this video, remember to like, share, and subscribe. And also let me hear from you by making your comments. Have a nice day.